Good morning, science champions. This is Ivor Thomas, your teacher for 10th grade high school students teaching chemistry. And today's learning objective is to create a graphic organizer that distinguishes between an Arrhenius acid and an Arrhenius base. So let's quickly settle down by counting from the valency of carbon towards the inert gas configuration. 4, 3, 2, 1, 0. Hush. Thank you for that quick settlement. Let's get into our lessons by looking at my hand, everyone. What's this? A lemon. What's its taste? Sour. What about this? Isabel, what is this? Vinegar. What's its taste? Sour. Here's a question to you guys. Why do things like vinegar or lemons taste sour? No idea? Here's a hint. Why do some things taste sweet? Samson. Because they have sugars. Awesome. Just like some things taste sweet because they have sugars, things like vinegar or lemons taste sour because they have acids. They have what? Acids. What are acids is what we are going to learn. But remember, when we learn acids, we need to also study about bases. When I say base, am I talking about this guy? No. When we say bases with acids in chemistry, we are talking about things that make your shampoos or your toothpastes. Acids and bases are complementary substances, just like in life sciences. When we study the DNA, what else do we study with it? The RNA. In geography, when we think about the north, what else do we think with it? The south. Just like that, acids and bases are things that go together, but they're totally different, and we will distinguish them. To help us distinguish, we are going to create a graphic organizer. Class, give me some examples of graphic organizers from the last bench. A pie graph, a line graph, a table, a bar graph. When we are going to distinguish two things, which graphic organizer suits us best? A table. So in 15 seconds, you will open a new page in your notebook, create a graphic organizer that is a table that looks just like this. It has 3 columns, 3 rows, and you will title it Acids Compared with Bases. The first column has a header property, the next acid, and the last base. Let's all do it. 3, 2, 1, done. I see some of you are finished, most of you are racing. All done now. Great. Now lift up your books and show it to everyone and see if it looks just like this. All of you are doing wonderful. Let's get into our lesson today. Books down, pens down, eyes and ears here, please. Thank you. The first distinguishing feature of an acid and a base are acids are sour to taste and bases are slippery and soapy to touch. Acids are sour to taste. Bases are soapy and slippery to touch. Here's a question. Is that good science to define something as sour and something as soapy? I hear a big no. You're right. To help us give a good scientific distinguishing feature of acids and bases, the first time it was a man called Svante Arrhenius. What's his name? Svante Arrhenius. He was from Sweden and he's a chemist and he won the Nobel Prize in 1903. So Mr. Arrhenius says that acids are substances that increase the hydrogen ion concentration in an aqueous solutions. Once more, acids are substances that increase the hydrogen ion concentration in aqueous solutions. When we think of aqueous, what do we know? Any idea? Hernandez, what is water called in Spanish? Agua. So agua comes from the root word in Latin called aqua. When I say aqua, do you think of something? Carlos says, Aquaman. That's a good observation. Aqua means water, and Arrhenius always dealt with solutions that were aqueous, which had water-based solutions. So he said that when an acid is introduced into water, it dissociates itself into an H plus, a hydrogen ion, and that hydrogen ion attaches itself to the polar water molecule, and it becomes something called the hydronium ion. So here we have a depiction of that equation. HCl gas plus water in its liquid form becomes H3O plus, which is aqueous, and Cl minus, which is aqueous. So this is called the hydronium ion, H3O plus. Similarly, to define bases, Arrhenius said that when a substance increases the hydroxide ion in an aqueous solution, that's called a base. Here we have sodium hydroxide, solid, with in water becomes sodium as a positive charged ion and OH, which is the hydroxide, as a negative charged ion. So that is the essential distinguishing feature of acids and bases. So let's transfer this learning into your graphic organizers, and I am giving you time to individually work. I see all of you have done your work. Now share it with your neighbor to check. Let's stop in 3 seconds. Wonderful. Now which two partners would like to share this to the class? Awesome. Carla and Amy have volunteered. Are they done? Have they got all of that right? Wonderful. So the third column which is left, we will deal it with the next class, where we will talk about the effect of acids and bases on metals and with electricity. But before you leave, here's an exit ticket for you to finish. And see you in the next class. Thank you so much.